How to evaluate higher order derivatives of Dirac Delta function. Suppose you are given first derivative or second derivative, third derivative or nth derivative of Dirac Delta function, or like delta dash x or delta double dash x or delta triple dash x, or the functions like delta dash x minus a or delta double dash x minus a, where you use shifting property of Dirac Delta function with higher derivative. Then how you can find out the or evaluate the Dirac Delta function? You remember these two formula, that is integration minus infinity to plus infinity fx delta nth derivative dx, that is equal to minus 1 whole to the power n nth derivative of the function at x equal to 0. If you have shifting property, that means the value of x is shifted from 0 to a, then this formula will tend to fx, the nth derivative of the delta function. In place of x you write x minus a dx, the same formula, that is minus 1 whole to the power n, and the nth derivative of the function at a. So let us prove this one. If you have nth derivative at x equal to 0 for the delta function is given, then you use the equation, the integration by parts. If you use integration by parts, that is the common formula, integration of u dv is equal to uv minus integration of v du. So using this formula, integration of u dv, this is your dv and this is your u. So the formula will be uv. If this will be dv, then this will be v. So uv and value of integration from minus infinite to plus infinite minus integration of v du. What will be your du? Du will be equal to f dash x and f dash x v du. What will be v? V will be equal to delta x dx. So if you substitute the value of upper integral minus lower integral, then this will be equal to 0, and this value will be equal to minus f dash 0, this one. As we have proved in previous video, if you have this type of function, Dirac Delta function, then the value of the Dirac Delta function will be equal to the function at x equal to 0. That means the function here is f dash x, so here the value will be equal to f dash 0, and you have a minus sign. And if you have formula, instead of delta dash x, if you have delta dash x minus a, then this is from the shifting property I have discussed in the previous video. That means the value of x equal to 0 has been shifted to a. Then the same formula, this formula will be fx delta dash, that means the first derivative of delta function at x minus a dx will be equal to minus f dash a. Here minus f dash 0 because at x equal to 0, here minus f dash a because at x equal to a. So if you have nth derivative of the delta function, suppose delta n is equal to the nth derivative of the delta function, then you have to repeat this problem and this integration n times. That means you have to use integration by parts n times. So repeating n times using integration by parts, what will be your formula? For x equal to 0, the formula will be minus infinite to plus infinite fx delta nth derivative of delta function dx, that is equal to minus 1 whole to the power n, then fn 0. Similarly, when x is at a, if you have x equal to a, then what will be the formula? Integration from minus infinite to plus infinite fx delta n, that means nth derivative of delta function at x equal to a, so x minus a dx minus 1 whole to the power n. Then nth derivative of the function at x equal to a, here at x equal to 0 and here at x equal to a. For example, suppose you are given to prove or evaluate fx delta double dash, that means second derivative of the delta function at x minus a dx, then what will be your answer? It will be equal to minus 1 whole to the power 2. So this will be equal to plus 1. Then second derivative of the function, that is f double dash at x equal to a. So f double dash a. In this way you can prove. So this is a very useful formula for to evaluate higher derivatives of delta function, that is first derivative or second derivative or nth derivative. That is why this will be the very useful to solve the various problems on delta function on higher order derivatives of delta function. Thank you.